Oh, hi there. I didn't notice you. I'm Zach Seville, Mission Commander for Hip Hop Rap and Girls Time, and today I have the pleasure of walking you through our new turbine, which as you can see is spelled with an I in the center. It all started with our first prototype, which was based mainly on straw, toothpicks, and paper. From this, we then moved on to a fully fledged final project. As you see here. This product will help us produce energy on Mars in order to get us off of the planet. I will now hand it over to our chief engineer to show you the underlying mechanics.
Oh, hello. As you see, Zach introduced you to our turbine. So here we have our orthographic view showing the top of the turbine, our 2 blades, and then 2 more blades, totaling 4 blades. Then here's our isometric view. What we were trying to optimize on our turbine was power output. If you take a look at the graph, you can see that we were able to generate a maximum of 0.2 volts. When you take into consideration the size of our turbine, this output is more than adequate. So to try and optimize power output, we used 4 blades. We know 3 blades is often optimal for turbines, but we want to try something different. So for our blade design, we have zinc sheets wrapped in tinfoil. This is so we can bend and deform our blades in any way we want. So we tried 3 different blade shapes. First we tried just a simple U shape and put it on the end, like so. Then we tried just one flat on the outside, and then we tried another flat on the inside. And if you look at the graph, you can see we kept the revolutions for each blade constant, and using a slow motion cell phone camera and timer, we plotted the time it took to complete a certain amount of revolutions. When the blades were placed on the inside of the blade spindle, it minimized the time for a certain amount of revolutions to take place. After we figured out that putting our blades on the inside of our blade spindles would be optimal, we decided to place them in front of the bottom blade spindle in order to allow air to push it this way. Air coming this way would push the blades this way, and air coming this way would allow these to flap up. This did not work. What we would do to fix this is decrease the friction of our blade spindles. As you can see here, we have our stopping mechanism. If you look at the back, it is just a popsicle stick, but it works just fine. As our turbine spins, you lift up the popsicle stick and it will break the mechanism. So originally, we tried to place the motor inside the dowel, but that did not work for the motor was too heavy. So what we did was we used the idea of rotary to linear method. So what keeps the motor in place from spinning with the turbine is the 2 wires from the Arduino. So why is this cork and clip here? Well, without it, our turbine would not spin at all. Even though it provides some friction, it still allows our turbine to spin. Next, what we have to protect the inside components of our turbine is a makeshift lock. So all our Arduino components go inside the turbine. We close it. One clip is attached here, and another clip is attached to a hole we made, and it locks it closed. And we are able to plug in our Arduino into our computer to test our power output. So how much does it cost to build a device like this? Well, we had 4 toothpicks, 1 wooden dowel, 1 box, 2 popsicle sticks, 7 alligator clips, 1 cork, 1 googly eye, 1 zinc sheet, and 1 roll of tinfoil. For our box, since we weren't able to use the box that was provided to us on Mars, we had to improvise, so we used a shoebox. Without the box, all of this cost 60 spaceship parts. With the box, it adds about, roughly, 58 spaceship parts. The reason why we overestimated instead of underestimated is because inside the box, there are folds in the box which adds extra cardboard. What would we do to improve our design? Well, instead of 4 blades, which we realized was not the most efficient, we would have 3 blades, each one 120 degrees apart. The reason why our prototypes work so well is because our blades were very close together and where the wind hit did not matter. But for our bigger turbine, when wind came at it with the big fan, both of these offset each other, and unless the wind hits from a specific angle, it would not spin. Now I'm going to hand it back over to our mission commander, Zach.
While I'm speaking to you now, our turbine may not be operational, but we hope to work very hard in the days ahead to get it into operational status. But besides that, allow me to walk you through some of the aesthetic design choices that we made. All day, I dream about spinning, and in order to do so, we chose a designer that would encapsulate our values for our turbine. And as you can see, Adidas fit the bill perfectly. Along with this, we have a stylized 7 to signify our team number. While our team name would be the preferred method of contact, we were forced to use numerical designations. Along with that, we placed SOS on our blades in order to signify for help. And to top it all off, our turbine gets its namesake from the googly eye that we placed on top. Unfortunately, at the time of filming, our communications officer, Sharanya Ganesh, has fallen seriously ill. We pray that she makes a speedy recovery in the future. And I'd also like to take this time to have a moment of silence for our fallen commander, Daniel Berkey. Thank you.